Days after perihelion, geometry turns austere, phase angles steepen, backgrounds grow busy, and yet NASA's new frames of 3I, Atlas cut a disciplined thread through the noise. On the outbound leg, it appears almost ordinary until a second look hardens the doubt. A whisper of Coma, a tight reflectance profile, the kind of ambiguity that invites method over metaphor. What the eye wants to decide, the pipeline must earn. Frames are bias and flat corrected, tracking rates nailed, and stacks built and unbuilt to smoke out artifacts. Stars define the point spread. Low-order trends are stripped before photometry. Morphology is tested against the field, not memory. Any hint of periodicity is treated as a proposal, not a promise. And every control is designed to make an illusion fail quickly. The stakes are simple and high. The object is faint, the cadence unforgiving, and each observing hour has to purchase clarity rather than story. If a pattern hides in these post-perihelion images, it must outlive calibration, replication, and the dull honesty of error bars. Natural or artificial is the public riddle. Instrument or signal is the working fight. The window is brief. 3I Atlas joins the ledger as the third interstellar visitor on record, after the flat profile puzzles of Oumuamua and the more textbook display of 2I Borisov. Interstellar is a kinematic verdict first. The fitted orbit does not bind to the sun under reasonable assumptions. Interpretation comes later. For this campaign, perihelion matters because it reshapes illumination and geometry, raising the odds that dormant volatiles, if present, briefly cross the threshold of detectability. Perihelion is a corridor, not a flash. As the object swings through, phase angle, distance, and apparent motion evolve together. Sunlight grows harsher on the visible face, biasing shape inference and compressing the useful range of exposure times. Crowded star fields lift the risk of confusion. Miss the tracking rate by a little, and the point spread lengthens, turning a compact source into a smear that can impersonate a tail. Every choice aperture, annulus, cadence either reduces those biases or bakes them in. The data ecosystem is intentionally plural. Wide surveys supply cadence and discovery context. Targeted facilities supply depth. Space telescopes offer stable point spread functions and dark backgrounds. Large ground mirrors trade weather for photons. Photometry builds time series for spin and aspect constraints. Morphology, work registration, stacking. Deconvolution tests whether any coma or tail survives. Comparison to field stars treated the same way. Spectral and thermal channels, when they exist, probe gas lines, dust color, and temperatures that anchor a physical model instead of a story. Every method brings failure modes, and naming them early prevents self-deception. Aperture growth can hide or invent variability. Flat field residuals masquerade as gradients. Deconvolution can chisel artifacts as easily as it reveals structure. Period searches love aliases when cadence is uneven. The only reliable antidote is replication. Independent pipelines, independent nights, independent optics. Agreement is not proof, but disagreement is fast at exposing the weak link and protecting scarce telescope time from mirages. Against that landscape, the baseline hypotheses stay deliberately simple. A natural body may be inert, weakly active, or dust-dominated without obvious gas. An engineered body, if it were even relevant, would need signatures that are specific and stubborn under calibration. The work therefore aims to bound curiosity rather than amplify it. Map the parameter space each hypothesis can occupy. Once geometry, instrumentation, and reduction biases are fully accounted for, and let the numbers, not adjectives, do the narrowing. The ignition is quiet but decisive. A fresh archive drop marked post-perihelion with images, calibration frames, and a short chain of engineering notes. File names are plain, geometry is favorable, and exposure times sit in the narrow band where trailing stays tolerable. This is the handoff from curiosity to protocol. Interesting is not enough. Features must be framed as tests that can fail. Objectives come in paired questions, so every claim has a control. First, natural versus artificial as a discipline, not a headline. Do the observables fit cometary or asteroidal behavior without special pleading? Second, signal versus instrument. Does a feature persist across reductions, nights, and optics, or does it wilt when a processing knob moves? Third, material and activity. If dust or gas is implied, can rates, colors, or temperatures be reconciled with solar input and plausible surface physics? Acceptance criteria are declared before touching the data. Photometric structure must clear a conservative signal to noise, repeat on independent nights, and survive alternative detrending. Morphological claims must vanish when tracking is intentionally offset and must match point spread comparisons against field stars processed identically. Spectral hints must center within a resolution element and show flat controls. Any non-gravitational fit must meaningfully reduce residuals without inflating parameter degeneracy. The plan runs as mini loops with hard stops. Loop A, photometry with parallel pipelines, aperture and PSF, cross-checking air mass trends, background choices, and false alarm rates for period searches. Loop B, morphology, registering on the object, stacking with sigma clipping, deconvolving with multiple kernels, and auditing artifacts against cosmic rays, star trails, and scattered light. Loop C, color, spectra, and thermal proxies, converting measurements into constraints on particle sizes or surface temperatures. Loop D, dynamics, fitting orbits with and without non-gravitational terms, tied to Gaia frames, and stress testing residuals by elevation and seeing. Anomaly handling is tiered to keep language honest. Tier 0 is noise or reduction whimsy. Tier 1 repeats within one instrument but fails a control. Tier 2 repeats across nights or pipelines with physical plausibility. Tier 3 is cross-instrument, robust to nuisance parameters, and survives stricter cuts. Only Tier 3 items move to interpretation. Lower tiers are logged, visualized, and parked. Confounders are written in ink before analysis. Background crowding, flat field residuals, subtle tracking mismatches, phase angle biases, cadence aliases, and confirmation pressure. To counter them, reductions are mirrored blind, parameter changes are versioned, and both pretty stacks and ugly residuals are archived. The operational rule is simple and enforceable. If a feature weakens under tighter controls, it is not a feature. The packet is open, the objectives are fixed, and from this point forward, the clock, the method, and the error bars share authorship of whatever the data will allow. Loop A starts in the time domain because spin, aspect, and activity write their signatures into brightness before they sculpt shape. Two pipelines run in parallel by design. The first is classical aperture photometry with growth curve checks. The second fits PSFs against field stars matched in color. Calibrations are routine but explicit. Bias, dark and flat corrections. Air mass trends modeled with low order terms. 0 points chained night to night with their uncertainties carried, not guessed. Detrending is treated as hypothesis, not housekeeping. An hour scale undulation must persist when the aperture grows, when the sky annulus shifts, and when crowded frames are removed. Lomsgargle searches run with conservative false alarm controls. Alias structure is mapped against cadence and weather gaps. If a periodicity flips sign after a different sky annulus or collapses when a faint neighbor is masked, It is not rotation. It is a warning. A candidate period appears too tidy to trust on first pass. Under PSF, fitting its amplitude shrinks but does not vanish. Under aperture photometry, it shrinks further when the background annulus avoids a dim star. Phase persistence across adjacent nights is suggestive, not secure. The team assigns Tier 1, a hint with caveats, explicitly labeled needs independent telescope and tighter cadence. No modeling is built on it. Curiosity is deferred to rigor. Loop B moves to morphology, asking whether the object is broader than stars everywhere, not just where memory wishes to see a tail. Images are registered at the object's motion and stacked with sigma clipping. Star stacks are built as a control. Isophotes are cut at identical surface brightness for target and references. Deconvolution uses multiple kernels, each derived from stars spanning color, brightness, and position, because a single kernel can carve fiction as easily as structure. A hairline asymmetry emerges at a position angle consistent with sunward geometry. It is narrow enough to be one kernel away from disappearing. Tests follow. Swap PSF stars, vary deconvolution strength, inject synthetic point sources at the target's brightness, then rerun the chain. The asymmetry weakens when kernels come from redder stars and strengthens with bluer ones, an instrumental color term, not a sky truth. The feature drops from tempting to fragile. Tier 0 to Tier 1, at most, archived with the synthetic injection panels, so the lesson does not evaporate when the plot is resized. Dust proxies are reported with full disclosure. AFRO estimates include apertures, phase corrections, and the exact calibration stars. Values sit low with broad error bars, consistent with either a tenuous coma or a compact, effectively inert body. A deliberate mistracking test, offsetting the rate by a small logged amount, collapses the earlier elongation into symmetry, the response expected if registration, not physics, had been responsible. Morphology retreats from the spotlight. Both natural and artificial hypotheses remain uncommitted. Loop C examines color and any spectral or thermal proxy the data can support without overreach. Broadband colors are measured after color term calibration against standard sequences in the same field. The trend is neutral to mildly red, compatible with space-weathered surfaces or fine dust, and far from any exotic spike that would demand unusual composition. Where low-resolution spectra are feasible, line candidates subside once slit losses, sky residuals, and resolution elements are accounted for. Nulls are written as limits with units, not as shrugs. Infrared photometry, when available, is translated into cautious temperature ranges using a simple thermal model with a stated beaming parameter. The envelope overlaps what solar input would produce at the present distance for modest albedo. An early outlier softens into consistency after a small log change in aperture correction is applied uniformly across nights. That paper cut is enough to demote a Tier 2 whisper to Tier 0 silence. The stack tightens. Loop D, contingent on precise astrometry, tests for non-gravitational acceleration. Orbits with and without A1, A2, A3 terms are fit against Gaia-tied star catalogs. Residuals are inspected for directionality and stability. Adding thrust terms improves chi-squared only when low elevation frames remain. Once the pre-declared elevation cut is enforced, the improvement evaporates. A dramatic inference dissolves into geometry and atmosphere. The non-grav case does not clear the bar and is parked without ceremony. With loops complete, the anomaly stack is assembled and read like a ledger. Photometry, a cadence-sensitive period, Tier 1. Morphology, asymmetry, anti-correlated with kernel choice, Tier 0 to Tier 1. Color and low-res spectrum, neutral to mildly red, lines absent at our limits, a consistent null that earns tier 2 only as a robust constraint. Thermal proxy within solar heated expectations once aperture corrections stabilize, tier 0. Dynamics, non-grav terms unsupported under rigorous frame cuts, tier 0, no tier 3 survivors, nothing cross-instrument, robust and resistant to nuisance parameters. The discipline now is to turn absence into boundaries. A faint or absent coma implies dust production below a stated floor. That floor is reported with aperture, phase law, and calibration stars attached. A light curve without a secure period still trims phase space. Large amplitude tumbling is disfavored when nights stay flat under independent pipelines. No required non-gravitational terms push exotic thrust ideas below our detection threshold or into time windows we did not sample. Each bound removes a rumor and leaves behind a narrower question. Confounders are closed out, not hand-waved. Background crowding is audited via artificial source recovery near the target path. Recovery rates match, arguing against selective bias. Flat field residuals are probed by field rotation between nights. A real tail rotates with the sun target geometry, not with the camera. Cadence gaps are simulated to estimate alias power. The candidate period survives only at the lowest confidence. Where control shrinks an anomaly, the figure pairs the before and the after are archived together to normalize the disappointment and memorialize the fix. Finally, the stack is tested against the temptation to over-explain. Could an engineered surface mimic neutral colors, minimal dust, and no thrust while passing every control we applied? Perhaps in story, not in the parameter space we sampled with these instruments under this geometry. The conservative portrait that remains is plain and earned. 3I, Atlas, as measured in this window, behaves like a natural body with weak or intermittent activity. That conclusion is not a flourish. It is the remainder after artifacts are paid, aliases are taxed, and the ledger balances to zero, where drama once claimed a surplus. Silence is a measurement with units. The post-perihelion frames do not show a flamboyant tail or a loud light curve, but they do fix ceilings. From conservative stacks, the team turns non-detections into upper bounds on dust production and on any gas lines that would have risen above the achieved signal-to-noise. Those numbers are not footnotes. They fence off entire districts of parameter space where dramatic behavior would have been inescapable. What does not appear becomes a contour on the map, labeled and dated. The time series speaks in the same register. A secure period does not emerge, yet amplitude limits still matter. If the body were tumbling with large aspect swings, the photometry would have wandered beyond propagated uncertainties across detrended nights. It did not. The quiet favors modest amplitudes or viewing geometries that mute variation. Even a null is a ruler. Extremely fast or extremely slow rotations grow unlikely when consecutive sequences remain flat under independent pipelines that disagree only within their error budgets. Dynamics add another kind of quiet. Orbital solutions without non-gravitational terms satisfy the residuals once low elevation frames are disciplined out by rule. If a steady thrust or venting large enough to steer the path were present during the sampled cadence, it would have declared itself. It did not. The absence of a required A term is therefore not emptiness, it is a threshold. Any exotic mechanism must now live below that line or explain a timing that neatly dodged every window we observed. A claim that grows weaker the more windows are added. Together, these silences cohere into guidance rather than drama. They prefer a natural body with weak or intermittent activity, surface colors that do not demand unusual chemistry, and thermal behavior consistent with solar input at the measured distance. They also validate the workflow. Artifacts shrink under stricter controls, and what survives control is quieter but more real. In this file, the supposed shock is what failed under method. The value is what those failures quantify, because the next proposals can point with numbers at smaller targets and ask narrower, testable questions. Silence, written carefully, is progress. A provisional image holds when the anomaly ledger is read for discipline, not appetite. Photometry, once cadence artifacts and background quirks are stripped, leaves at most a modest, cadence-sensitive hint, too slim for a spin model, firm enough to cap amplitudes. Morphology, punished with star controls and synthetic injections, will not sustain a sharp tail or knife-edge coma beyond Tier 1. Color and low-resolution spectral work align with ordinary, slightly reddened surfaces. Thermal proxies sit where solar heating would put them at the current distance. Astrometry does not require non-gravitational terms once low-elevation frames are down-weighted by rule. Nothing clears. Tier 3, several candidates fold into Tier 0 under stricter cuts. The working resolution is unvarnished and robust. Within present limits, 3i, Atlas behaves like a natural body with weak or intermittent activity. That sentence earns weight because of what it excludes. Large, persistent dust production is unsupported at achieved depths. Dramatic compositional signatures are absent at available resolution. Sustained thrust of a magnitude that would reshape the orbit is not demanded by the residuals. Each negative is a numeric fence. Taken together, they evict high-drama scenarios from the slice of parameter space actually sampled. Artificial is not outlawed in logic, but in this window, it has nowhere comfortable to live. Costs keep the resolution honest. The post-perihelion geometry forced exposure times into a compromise between trailing and depth. Information was left on the table to preserve shape. Weather and scheduling carved cadence gaps that inflate alias risk and blunt any period claim. Duplicated blind pipelines consumed time early but paid down bias. The trade-off was fewer nights reaching the same standard of reduction. Space assets, with their stable point spread and dark backgrounds, were limited. Every marginal hint pursued is an hour not allocated to cleaner targets. Proposal pressure is a currency, and it was spent conservatively. Scientific trade-offs are explicit. Conservative apertures to avoid contamination, dull sensitivity to ultra-compact Coma. Strict elevation cuts trim the faintest frames where a borderline effect might have lurked. Cross-instrument confirmation raises reliability at the cost of speed. By the time a second optic repeats a hint, geometry may have moved on. These are not mistakes. They are the price of claims that outlive their plots. What could overturn this resolution is clear and actionable. First, a dense multi-night light curve with hour-scale cadence could secure or kill the suspected periodicity and, with it, sharpen constraints on shape and aspect. Second, deeper imaging at gentler phase angles, preferably with stable space-based optics, could push morphology and dust limits down another factor, deciding whether today's nulls are geometry's trick. Third, targeted spectroscopy or mid-infrared photometry with higher resolution and tighter control fields could expose faint gas lines or thermal excess, our current work only bounds. Until such data arrive, the cautious reading stands. The post-perihelion packet did not crown a mystery, it audited one. Each stricter control demoted a surprise. Each bound earned a narrower question. The cost was time. The return was clarity. If the conclusion feels unspectacular, that is a property of the sky, not of the method. Most objects behave normally most of the time. The science is stronger for having tried to break that statement and failed, because the next proposals now point at smaller targets with sharper tests, and the story they tell will have fewer places for artifacts to hide. The next window is set by angles, not calendars. As 3i Atlas recedes, solar elongation improves before the flux falls through practical limits. Somewhere in that crossing lies a cleaner geometry, softer phase angles that ease morphology, steadier backgrounds that calm photometry, and sky motion slow enough to keep the point spread honest without starving the counts. Readiness is the plan. Calibrations rehearsed, control fields chosen, Q slots negotiated so that the moment geometry cooperates, method is already in place. Priorities track the gaps rather than the headlines. First, a contiguous light curve campaign with hour-scale cadence across multiple nights to either lock the suspected periodicity or dismiss it outright, turning suggestive phasing into a number or a null with teeth. Second, deep imaging under Kinder phase with stable optics, so any asymmetry must compete with physics, not with kernels. The success criterion is explicit surface brightness limits reported with apertures, phase laws, and reference stars. Third, spectroscopy or mid-infrared photometry at higher resolution framed by better control fields to convert today's upper bounds on gas and temperature into detections or tighter ceilings. Observing economy is part of the science. Ground facilities can supply cadence and redundancy. Space assets supply stability and darkness, but demand harder cases. That case is stronger now precisely because the last campaign audited itself. Proposals can point to quantified floors on dust and acceleration, to reductions that retired artifacts, and to questions narrowed by numbers. Time is a currency, prudence earns it. Reflection returns to the opening hook with quieter terms. The post-perihelion packet did not hide a revelation. It revealed how claims behave under stricter controls. Features that wilted became constraints, and constraints are the skeleton of progress. What remains is a smaller target, a natural body with weak or intermittent activity, whose properties can be tested again when angles turn kinder. The promise, then, is not drama but traction. When the geometry opens soon enough for persistence to matter and late enough for preparation to help, the same discipline will be applied with longer cadence, deeper stacks, and sharper controls. If a pattern lives in 3i Atlas, it will show in that overlap between better sky and harder standards. The window will open again. The questions are ready, the thresholds are written, and the method, having traded flourish for clarity, knows exactly what to try next.